Alright, we're back with number 3 on the practice exam. It's asking us again to work with the continuous time Fourier transform. We've been given x of j omega. It's this graph right here. They want us to find x of t. So we go to the table of Fourier transforms. In this case, we're going to be working backwards. We've been given x of j omega. We want to find x of t. So just go down and search. I got it for us already. It's here. So x of j omega is equal to 1 if omega is less than a or greater than minus a. So we have that condition here. It's a rectangular pulse of width pi over 2, so we can just write this directly. X of t equals sine of, in this case, a is pi over 2 divided by pi t. Okay, now let's move on to B. It asks us to sketch the Fourier transform of P of t equals cosine pi t over 2. So we go to our table of Fourier transforms. We see that cosine omega naught t is going to map in the frequency domain to pi delta omega minus omega naught minus delta omega plus omega naught. In this case, omega naught is pi over 2. So these are just impulses, shifted impulses with weight pi because of the pi out front. So we have one in the right half side of the plane at pi over 2. It is here. And then we have sorry, I said minus, this is plus. One at minus pi over 2. This was plus right here. Okay, that's B. So now let's go to C. It's asked us to sketch y of j omega if y of t equals x of t times p of t. We're given both x of t and p of t. You could do this in the frequency domain. However, multiplication, if one of the benefits of the Fourier transform is that convolution in the time domain is equal to multiplication in the frequency domain, but one of the downfalls is that multiplication in the time domain is equal to convolution in the frequency domain, we have delta functions, so we have a nice property for that, but in this case, we also have a nice trig identity. So we're going to write y of t equals p of t, which is cosine pi over 2 times t, and x of t is sine pi over 2 t divided by pi of t. Okay, we know that the double angle formula is for sine and cosine is sine 2t equals 2 sine t cosine t. So here we can multiply by 2 over 2, because that's just 1, so that's valid. So we get y of t. Okay, now we have the identity here, so we get sine of pi t divided by pi t. Can't forget the 2, so 2 pi t. So now we can write that as just 1/2 times sine pi of t divided by pi of t. You probably recognize this from 1. We said that from the table of Fourier transforms, we said that sine of we said sine of at divided by pi t maps to we'll call this z of t. Then z of j omega is equal to 1 for a absolute value of a less than 1. Absolute value of omega less than a, or 0 for absolute value of omega greater than a. So we can't forget our factor of 1 here, so y of t 1/2 y of t we can write as equal to 1/2 z of t assuming that a is pi. So we can say then that y of j omega is equal to 1/2 omega less than pi, because that's our value of a. So the value of omega greater than pi. So now we can sketch it. It's a rectangular pulse of width 2 pi. It's got an amplitude of 1/2. And like I said before, you could have done the convolution of p of j omega and x of j omega, which I believe is how Professor Wang's solution to the practice exam does it. That's perfectly valid too. So that's number 3. Okay, bye.